Hello once again EDP students, this is m.felicetti and in this video I will take you through some basic digital concepts. So let's start. So say we have a thermometer and this thermometer is an analog thermometer. So this means that if we plot the temperature versus time, we get a continuous line. And theoretically we can get the exact value of the temperature at any point in time if we're able to measure it. So for example, shown here, we have 8.64321, etc. Whereas, if we had a digital thermometer, like the one shown, you can see this one, the one I have, is only allowing one decimal place. So the resolution of this digital thermometer is limited to 0.1. And we cannot measure the exact value at any point in time. We could, however, increase the resolution, but then we're limited to that resolution still. So this can be seen on this graph here, that we get discrete steps rather than a continuous line when using digital. So with using digital, it's important to know that digital data can only be stored to a given resolution, as computers do not have infinite memory. So what we're going to look at now is digital signals. So let's say we have a USB flash drive. Now a flash drive, when used on a computer, needs to communicate with that computer. And this is done by sending data and commands. The signals we sent would look something like this. We can see that the signal is varying with time, but only changing to two discrete values. This is a high and low voltage. And these could be any values depending on what signals are being sent and where this is used. So to make sense of this, let's get rid of the USB and let's use a light instead and see how it acts over time with this signal. So at the start, we have a low voltage and the light is off. We then reach this point and our light turns on for a certain amount of time. We go down to low again and our light turns off. We go up again and down again. So our light turns on and then off. Then our light turns on for a long time. And then we go low very quickly and low very quickly 2 times in a row. Something like this. So we can see by using high and low that we can manipulate and make our light flash at varying rates. So this high and low that we've been talking about is known as binary digits. So these are 0 and 1, where 1 is high and 0 is low. So let's continue now that we know this and look at some logical operations. So the logical operators change the logic of binary signals. So the first and most basic logic operator is NOT. And it has a symbol like this. And what this is saying is X signal comes in and Y signal comes out. So we've got an in signal and an out signal. So let's put this in a table to see what happens when X goes in and what comes out. So if X is a high or a 1 going in, then we get a 0 out. Whereas if X is a low or a 0 coming in, then we get a 1 coming out. Okay, so you can see that it's inverting the signal. The next logical operator we're going to look at is AND. So it has a symbol like this. And you can see for this one, we've got two signals coming in and one signal coming out. So let's put together the table for this. When we have a 0 and 0 on our input, we get a 0 on our output. When we have either a 0, 1 or a 1, 0, so there's a 1 on at least one of these, then we get a 0 and a 0. Okay, so when these are both different from each other, we get a 0. But when they're both 1s, we get a 1 out. So if they're both high, we get a high out. So an AND, if this one's high and this one's high, then we get a high. Or this one's 1 and this one's 1, then we get a 1. The next one we're going to look at is OR, and it has a symbol like this. So we've got two inputs and one output again. We'll put together our table, and we'll notice that when A and B are both 0, we get a 0 out. When they're both different, so we've got a 0, 1 or a 1, 0, we get a 1 out this time. And when they're both 1, we get a 1 out. So as long as one of these inputs is a 1, we get a 1 out. And the only case that we get a 0 out is when both our inputs are 0. Now the last logical operator we'll look at is XOR, and this has a symbol like this. The table follows, and 0, 0 is the same as our OR and AND once again. Our 0, 1 and 1, 0 is the same as our OR. But when we have a 1, 1, we get a 0. So this is an exclusive OR. So both the inputs need to be different to get a 1 out. Thank you very much.